Okay, we want to take a look at the ion product constant for water. So if we take any sample water, it doesn't matter how large of a sample, how small of a sample, how pure or impure the water is, water on its own will ionize to form proton and hydroxide. While at the same time, the proton and hydroxide will reassemble to go back and form liquid water. Now, because we have an equilibrium established here, we can write an equilibrium constant for this reaction. And that's going to be KEQ is going to be equal to our proton times our hydroxide. Notice I did not include the water because water is a liquid. We don't include liquids or solids in the equilibrium expression. Now, this is a special KEQ because it is for water, and so we're going to change KEQ to KW, which stands for the ion product constant for water. Because after all, we are multiplying together the two ions, the product for it, and it's for water. All right, so this KW expression is actually quite powerful, and we can use it so that we can convert between proton concentration and hydroxide concentration. For example, here's our KW expression. So let's say we happen to have pure water at 25 degrees Celsius. At 25 degrees Celsius, we will find that our proton and hydroxide concentrations will both be equal to 1 times 10 to the negative 7th mole per liter. Therefore, Kw would also be then equal to 1 times 10 to the negative 14th, because you would take the 1 times 10 to the negative 7th, which would be the proton concentration, and the hydroxide 1 times 10 to the negative 7th, multiply the two together, and of course you get 1 times 10 to the negative 14. So, get a situation here. We're going to see which solution will be acidic, which will be basic, which will be neutral. If the proton and hydroxide concentrations happen to be equal to each other, we would have a neutral solution. When you have more proton than hydroxide, you have an acidic solution. Then conversely, if you have more hydroxide than proton, you have a basic solution. Let's take a look at an example here. So if our proton concentration is 1 times 10 to the negative third, let's calculate the hydroxide concentration. So our formula is going to be Kw is equal to proton concentration times hydroxide concentration. Now we want to solve this equation for hydroxide. So what I've done is I've divided both sides by proton concentration. Substituting in, I have hydroxide be equal to the value of Kw, it's a constant, it will always be equal to 1 times 10 to the negative 14th, divided by the proton concentration given to us in a problem, which is 1 times 10 to the negative third. Solve, and we get a hydroxide concentration of 1 times 10 to the negative 11th. So for this particular problem, because our proton concentration, which was 1 times 10 to the negative third, is greater than the hydroxide concentration, which is 1 times 10 to the negative 11th, in this particular problem, we had an acidic solution.